We are continuing our study of related rates. You just saw an example of a volume problem using a sphere. So you saw a nice little balloon problem. Today we're going to look at a circle problem, specifically with area. All right, so our story says, a stone dropped into a still pond sends out a circular ripple whose radius increases at a constant rate of 3 feet per second. Okay, so we have this circle that is growing, growing, growing. How rapidly is the area enclosed by the ripple increasing at the end of 10 seconds? So I know I'm working with area. Our formula for area of a circle is pi r squared. And in terms of my diagram, the only measurement we care to work with is the radius. And as the ripple extends out, the radius will change. So we're going to leave that as r. You can differentiate this now, or you can get your other information laid out if you like. So they tell us that the radius increases at a constant rate. This is a rate that the radius is changing. So that is going to be dr dt. And it's changing at a rate of 3 feet per second. That radius is growing, so this is going to be a positive 3 feet per second. How rapidly is the area increasing? So we are finding dA dt, the rate of change of area with respect to time, at the end of 10 seconds. So when time is equal to 10 seconds. Okay, so we've got our formula. I'm not going to substitute any values in yet. I've got to differentiate this, which will generate my rates. So the derivative of a is 1, but I just differentiated a, so I need dA dt. On this side, the 2 comes out to the front as my power rule. So 2, the pi just carries down as a coefficient. My power of 2 drops down to a 1. And then we've got the rate of change of r, so that's dr dt. And then from here, I am looking to substitute in whatever I have, whatever I know. So in this problem, I'm finding dA dt. So I don't know that. That's going to be my variable. Let's bring down my 2 and my pi. I do know dr dt. I don't know my radius just yet, but remember they gave us this little piece of information that time is 10 seconds. And so in this problem, if they told me that the radius is changing at a rate of 3 feet per second and 10 seconds have gone by, that really means that my radius is going to be 10 seconds times 3 feet per second. It is going to be 30 feet wide. That is a large ripple. So this is just a variation of another way that they can present information to you by giving you a time unit, and you have to actually use the rate that they gave you to calculate the radius. So I'm going to substitute 30 in for my radius, and I know my dr dt is 3 feet per second. And we're going to clean this up. So 30 times 3 gives me 90, times 2 is 180 pi. And our area measurement would be, our distance measurement is feet, so area would be feet squared. And our time measurement is in seconds. So that would be 180 feet squared per second. And my area is increasing, so I would expect that to be a positive rate. Okay, thank you so much for listening. Good luck with your circles and spheres today.